This is the third video on verifying trigonometric identities. So let's verify that sine of x plus sine of 3x over cosine of x plus cosine of 3x is equal to tangent of x. As always, I start thinking about the algebra. What I notice the most about this one is not only am I going from a fraction to not a fraction, which tells me that something has to cancel out, but I notice the arguments. I have arguments of x and 3x on the left, changing to an argument of 2x on the right. So I want to be thinking about some kind of formulas that I have that change the argument. And we're trying to get to tangent of 2x, so my second to the last step, I'm thinking that maybe sine of 2x over cosine of 2x would turn into that tangent of 2x. So I want to go from the sum in the numerator and the sum in the denominator to a single term plus change the argument. Well, our sum to product formulas will accomplish that for us. Starting with the left-hand side. And then we want to use our sum formula for sine plus sine. This is going to be 2 sine of x plus 3x over 2 times cosine of x minus 3x over 2. And in the denominator, we'll use our sum to product formula for cosine. This turns into 2 cosine of x plus 3x over 2 times cosine of x minus 3x over 2. So let's clean up those arguments. X plus 3x is 4x, divided by 2 is 2x. And then for cosine, x minus 3x is a negative 2x, divided by 2 is negative x. In the denominator, x plus 3x divided by 2, that gives us 2x like the numerator. And x minus 3x over 2 gives us negative x, also like the numerator. Next, we want to look and see if anything cancels out. Notice I have 2 over 2, so those will cancel out. We also have cosine of negative x over cosine of negative x. Those will cancel out. And recall, we can only cancel out when we're in factored form, and since we turned our sum into a product, everything is in factored form. This gives us sine of 2x over cosine of 2x, and we know that sine over cosine is tangent. This turns into tangent of 2x, which is our right-hand side. Let's try another one. In this example, we want to verify that sine of theta minus cosine of theta quantity squared is equal to 1 minus sine of 2 theta. Well, right away I noticed that I have different arguments, theta on the left and 2 theta on the right. So I'm going to do some side thoughts about that sine of 2 theta. Our double angle formula for sine says that sine of 2 theta turns into 2 sine of theta cosine of theta. And that gets us down to a more basic argument. Frequently, I'll start on the side with the more complicated argument, but if I do that, I don't really see how I'm supposed to get from 2 sine cosine to that sine minus cosine quantity squared. So I'm going to keep this side thought, but I'm actually going to start the identity on the left. Let's take this binomial, write it twice, and multiply it out. See if we get something that ends up looking like 2 sine cosine, and then we can substitute sine of 2 theta in for it. So writing our left-hand side twice. And now we'll multiply it out. Sine times sine is sine squared. Sine times negative cosine is a negative sine cosine. And then negative cosine times sine, that's another negative sine cosine. And then lastly, negative cosine times negative cosine gives us a plus cosine squared. We've got like terms here in the middle that we can combine. This is sine squared minus 2 sine cosine. So now I'm feeling good about that because my side thoughts for my sine of 2 theta is 2 sine cosine, and that's what I'm coming up with right here. Plus cosine squared. Now look that what we have is sine squared plus cosine squared. And that's our most basic Pythagorean identity. Sine squared plus cosine squared is equal to 1. So I'm going to substitute 1 in the place for that. But we have 1 minus 2 sine cosine. And we've already established that 2 sine cosine is equal to sine of 2 theta. So this becomes 1 minus sine of 2 theta. And that's our right-hand side. So I'm going to demo one more, but as I've mentioned over and over, it's really important with these identities that you do a large volume to practice because there's a lot of different, algebra techniques that are used, and with more examples, you're going to see those techniques easier and easier. Lastly, let's verify that secant of 3 pi over 2 minus x is equal to negative cosecant of x. So let's think about what we're saying. Right away, I see, secant and cosecant, which I'm not excited to see about anytime I'm doing an identity. But I also notice these arguments, going from an argument of 3 pi over 2 minus x to an argument of just x. We're going to have to take that difference argument and get rid of it. Now, we don't have a difference formula for secant. We only have them for sine, cosine, and tangent, so I'm going to have to turn this into one of those functions that we actually have a formula for. So we're going to start with our left-hand side, and we're going to rewrite this as 1 over cosine of 3 pi over 2 minus x. Now we're going to use our difference formula for cosine in the denominator. Our difference formula for cosine of 3 pi over 2 minus x is going to be cosine of 3 pi over 2 times cosine of x plus sine of 3 pi over 2 times sine of x. Well, 3 pi over 2 is on our unit circle, so we should be able to get exact values for sine and cosine of that angle. Now, cosine of 3 pi over 2, which we remember is down here at the bottom, our cosine value is 0, so this becomes 0 times cosine. And sine, down there at 3 pi over 2, is negative 1. So we'll have that times sine of x. Oh, the 0 times cosine, it disappears. And we are left with 1 on the top negative sign of x on the denominator. And remember what we're trying to get to. We're trying to get to negative cosecant. 1 over sine is cosecant by definition. So this is negative cosecant of x. And there's our right-hand side. I hope these 3 videos have showed you a variety of identities and algebra tricks and tools that you're going to have to pull from. I encourage you to do quite a few more.